First things first, so good morning everyone and welcome to what I have no doubt will be an absolutely fascinating session on how semiconductors will drive forward the net zero transition. This webinar is the second in our 2024 series and falls actually within our falls within our Unleashing Innovation campaign week. During this week, we're going to be exploring what are the emerging and transformative technologies at the heart of UK research and innovation. Each day of this campaign week is dedicated to a certain technology. So yesterday was quantum, tomorrow is AI and compute, Thursday is gaming, Friday is robotics and automation, which of course then leaves us to today, which is semiconductor technology. Thank you all for taking the time to tune in. I think this is going to be super fascinating discussion. Over the next 90 minutes or so, we're going to be exploring what are the ways in which semiconductor technology is not just important, but absolutely critical to net zero, from, kind of enabling new green technology to as well decarbonising other sectors. We'll be hearing from 5 expert speakers. So kicking us off will be 𝗨𝗨𝗶𝗶𝗀 from CSA Catapult, then Tigran from Deloitte, Professor Paul Meredith from Swansea University, David Verity from Pragmatic, and Manuel from Dassault Systèmes. I'll give them all a chance to introduce themselves before they present, but after these 5 presentations, each lasts about 10 minutes or so. That should take us until about 11:10, in which following that we'll then have a short question and answer session. So that will then be chaired by my colleague Mia, who's on the call, who's our kind of previous net zero program manager. So thanks, Mia, for joining us for that. For those of you who may be unfamiliar with techUK, we're the UK's biggest trade association for the tech sector. We have over 1,000 members. About 2/3 of those are actually SMEs. We're also a leading voice in sectors ranging all the way from AI to quantum to aerospace, as well as things like cybersecurity, healthcare, and of course, sustainable tech. We also play a leading role in the CHIPS Coalition, which is the industry voice advocating for the semiconductor industry. As I'm sure all of you are aware, semiconductors are one of DSIT's 5 technologies of tomorrow and will be a bedrock to the UK's science and tech ambitions. As the semiconductor industry is projected to grow, so will our need to move towards a sustainable future. That's why we were hoping today to leverage the amazing expertise and knowledge of our speakers to find out how those 2 fates are entwined. We'll be exploring where the industry's headed, what challenges lie ahead, and how this will impact future society and industry. Before we begin, just giving some quick house rules. So this session is of course recorded, so we'll be putting it up on our techUK website afterwards. And I'd ask that unless you're a speaker, can you please turn your camera and microphone off? For the question and answer session, please use the chat function. And I want to emphasize, of course, that this shouldn't just be a conversation between me and myself and the speakers. We're keen to get as much engagement from you as we can. So please do put any and all questions that come to your head into the chat function. And yeah, we're looking forward to what should be a really interesting and fruitful session. So without further ado, first presentation is from 𝗨𝗨𝗶𝗶𝗀. So if you'd like to screen share and we can begin.
Thank you very much, Alice. Just wait for this to load up. Hopefully you can all see the main slides.
We can, yes, we can.
Just taking a little while to load. Okay, there we go. So good morning, everyone. My name is 𝗨𝗨𝗶𝗶𝗀 and I am a business development manager at the CSA Catapult. I work with the 𝗨𝗲 and microwave group, looking at applications into telecoms and space comms. But today I'm here to talk about how the CSA Catapult is empowering a sustainable future. So who is the CSA Catapult? Well, we're a research and technology organisation and we focus on compound semiconductor applications across a wide range of market segments. We focus on 4 main technology areas. These are power electronics, photonics, 𝗨𝗲 and microwave, and also advanced semiconductor packaging. Through collaborative and commercial R&D programs, we aim to de-risk and accelerate the R&D cycle and really help our partners get to market faster. We're one of 9 catapults that span over 50 locations across the UK, and we're co-funded through Innovate UK. So how does the CSA Catapult make an impact? Well, our remit is to really bridge the gap between the UK's world-class academia and industry and help to pull through advances in compound semiconductor technology into real-world applications. We're co-funded and we've been up and running since 2018. We're also really heavily invested in skills and actively looking at ways in which we can address the skills shortage, which obviously is a huge issue at the moment across all sectors. So the CSA Catapult is headquartered in Newport, South Wales. We have an innovation centre there with multiple labs for each of our technology areas. We're also nicely situated in South Wales within the CS Connected cluster, which is the world's first compound semiconductor cluster. Clusters are a hot topic, and obviously we know that they drive economic growth. So we've also opened up sites across the UK to better support these regions. In Scotland, we have high power industries such as transport and energy. Northeast is telecoms and satcoms, and in Bristol we've recently opened our Future Telecoms Hub, which is a translational research centre that focuses on quantum and telecoms as well. So if you're on this call, it's highly likely that you're already aware of semiconductors, but you may still be unsure about what we mean by compound semiconductors. So I've just put together a few fast facts to make sure we're all on the same page as we progress through the presentation. So obviously we know that silicon is the most common and popular semiconductor material, and it's in most computers and most electronic devices. Well, compound semiconductors are basically the clues in the name. It's compound. It's made of two or more materials. About 20% of the world's semiconductors are compound semiconductors, and they can do things that aren't possible with silicon. They outperform silicon in three main areas. So that's speed, power, and light, which enables them to be smaller, lighter, faster, and more energy efficient, contributing to a lower total cost of ownership. So this final point is really where we see the main benefit and see how compound semiconductors are really helping build towards a sustainable future. If you think about an example of sending maybe a satellite into space, you know, every single gram matters when you're having to use all that fuel to get it up there. If you can make the electronics smaller and lighter, you've got energy savings there already, let alone additional energy savings from the electronics itself. You may have heard this last point referred to as 𝗬𝗲𝗃, which is size, weight, and power and cost, which doesn't really flow off the tongue as well as 𝗬𝗲𝗃 does. But this is really the key area in which compound semiconductors addresses and why it kind of reaches across all industries, because it can really help every industry benefit. So compound semiconductor technology unlocks new opportunities for innovation and efficiency across various industries. But continued investment into R&D is crucial for driving progress towards our net zero goals. So I'm going to take you through a few of the application areas in which CSA Catapult work and the role that the compound semiconductors play in building a sustainable future. One of probably the first example that comes to your head when you think of driving towards net zero, it's got the word drive in it, it's electric vehicles. So not only just we see it in things like scooters and cars, but also off highway, so trains, even things like tractors, agriculture, kind of a lot of industries can benefit from this. And compound semiconductors are essential in the development of these electric vehicles. So by enabling the efficient management of power in electric drivetrains, it can lead to longer driving ranges and also faster charging times. Sorry, I've just lost my place. So gallium and silicon-based power electronics contribute to reducing the overall weight and size of these components. The image I've got there is of an inverter, which is based from silicon carbide. And this is a project that we worked on within the Catapult, with the end customer being BMW. Now, we know that when we look at the automotive industry, cost is a major challenge, especially for widespread adoption. And additionally, ensuring the durability and reliability of these compound semiconductor components in the harsh environment is crucial. But from what we've seen on projects that we worked with, the benefits definitely outweigh the cost. And we all know that this is the path forward for helping to achieve decarbonisation and net zero in this industry. Slides. The next one we work in, and this is my area, is telecoms. So you may have heard before, gallium nitride, gallium arsenide, indium phosphide, they're all crucial in telecommunications infrastructure, such as 5G networks, and obviously as we go on, 6G networks. So these materials enable high frequency and high speed communication systems. So we need something that supports the growing demand for data transmission and while minimizing energy consumption. In 2023, it was estimated that the telecoms industry is responsible for 2 to 3% of the total power consumption of humankind. Like, I cannot emphasize enough how massive of a number that is. And base stations, like the image itself, consume 70% of the power consumption across the telecoms network. And we've got our own analysts within the 𝗍𝗍 Catapult, and they have found that within a typical base station, power amplifiers, which is this chip here, can account for up to 80% of the power consumed. This just shows how much of a sizable opportunity there is to drastically increase the energy efficiency by improving just one single device. 𝗍𝗍 Catapult analysis also shows that RF power amplifiers present one of the biggest market opportunities within the network, the global market set to grow to $9 billion by 2025. So some of the challenges that we see with telecoms is obviously the integration challenges, such as heat management and signal interference. And this happens as communications basically become more complex and more compact, making everything smaller, it gets a lot hotter. Also, interoperability amongst different components, different systems is a challenge that we see, but we are slowly starting to address. Our RF team has been involved in several R&D projects looking at optimizing energy efficient power amplifiers. And this is through exploration of different architectures and increasing the linearity of these devices. Now, base stations are only one aspect of this. So obviously in an increasingly digital age, we are creating, transmitting way more data than ever before. This is just a small snippet of where you see like IoT, people have got the watch, they've got the car. And as we go on and as technology advances, where we see self-driving cars, all of those sensors that are everywhere in our homes, in outdoors, all need to transmit that data somewhere. So these in the coloured boxes are just the areas that we're looking at in the Catapult and how to address this to make sure that it is sustainable. So in all of the ones in green are for RF. So we're looking at embedded die antenna in package. And again, this is putting the antenna into the chip itself, along with, maybe a power amplifier. But it's really to make all the components smaller. So if you think of a massive base station, how do you get it down to a very, very small box that will be more inconspicuous and can be better integrated into our society so we don't feel like we're just living around loads of base stations? And we're looking at RF beamforming and beam steering. How do we reduce interference and how do we make sure people are getting the right data? How is it getting to the macro cells or to the small cells? Also, we've started integrating it with photonics. So we look at RF over fiber for faster communications, photonic integrated circuits, and even things like beam steering with optical phased arrays. So this is using LiDAR, so that's light detection and ranging. So a few of the other areas that we are actively involved in is quantum. So quantum computing, we know, has the potential to revolutionize optimization and simulation tasks in various industries. And this can include logistics, anything from material science to drug discovery. And by enabling more efficient and accurate simulations, compound semiconductor-based quantum computing technologies can support sustainable practices and reduce resource consumption in these areas. So these materials used within quantum technologies can enable the creation of high-performance qubits and other quantum components, which again, looking at efficiency and reducing size. So often one of the challenges we see is with materials. So compound semiconductors are often composed of elements that are less abundant than silicon. So this can be gallium and indium as well, is two kind of materials that we've seen shortages with. However, they can be more readily recycled due to higher value and lower abundance. And I think it comes back to the thing of making something that will last much longer and perform a lot better is worth the cost, rather than buying, we see cheap electronics, silicon, they're thrown in the bin, they go into landfill. So it's just the trade-off between those. One of the other aspects we look at is in data centers. So it'll come as no surprise that data centers consume a lot of energy, and a lot of this is to go into the cooling. So the computer stacks generate a lot of heat, and to prevent overheating, water cooling is typically used. There was a study done by the University of California, and it said just one conversation with ChatGPT consumes around 500 milliliters of water. So it's like a small bottle of water. But one Bitcoin transaction uses enough water to fill a swimming pool, which is absolutely unreal. So compound semiconductors can improve the efficiency of data center cooling systems by using GaN-based power electronics. These generate less heat and have higher thermal conductivity compared to silicon-based components. And this then reduces the energy required for cooling. Additionally, gallium arsenide-based thermoelectric materials can be used for waste heat recovery. So this can be used to convert excess heat into electricity and further improve the energy efficiency. In addition, advances in semiconductor packaging techniques also enable smaller, more efficient and higher performing applications. In this example, it would mean a data center is able to process a lot more data in each building without needing to expand their physical footprint, therefore reducing the total cost of ownership. And lastly, I just want to touch upon sensing. So innovations in compound semiconductor-based photonics and optoelectronic technologies are driving advancements in areas such as lasers, photodetectors, and optical sensors. And this obviously feeds into applications such as healthcare, communications, agri-tech, and environmental monitoring. The challenge with this is achieving precise control over the optical properties and device performance is crucial, but really, really challenging. Additionally, integrating photonic components into existing systems is really, really complex and requires a lot of collaboration and standardization efforts. Compound semiconductors are obviously used in the development of quantum sensors, which have applications in environmental monitoring, precision monitoring, and healthcare. These sensors contribute to sustainability efforts by enabling more accurate and efficient monitoring of environmental parameters, which means that companies can have better resource management and therefore reduce the waste as well. So the power of compound semiconductors and their applications cannot be underestimated. They are transforming how we will live and work in the future, and we're only just starting to scratch the surface of what we might accomplish and how we might use compound semiconductor applications to hit net zero targets and contribute to a more sustainable future. That concludes my presentation, and if you would like to talk further on any of these points, please do reach out and get in touch. Thank you.
Brilliant, amazing. Thank you so much, Sally. God, that fact about for every conversation with ChatGPT, it's a 500 milliliter bottle of water. I'm not sure if that's like hilarious or terrifying, but yes, it's super, super interesting. And of course, compound semiconductors being identified in the national strategy as kind of a top for UK strength, right? And you can see why just looking at the applications today, let alone over the next few decades. So yeah, super fascinating. And again, a reminder to the audience that if you have any questions, please do pop them in the chat. But yeah, thank you so much, Sally.
No worries, thank you.
Brilliant. Yeah. So I believe our next speaker is Tigran. If you could stop screen sharing, Sally, please. And yeah, we'll be hearing from Tigran from Deloitte.
Thanks, Ali. Great presentation. Thanks, Alice. Enjoyed a lot. Appreciate it. So I'm Tigran. I work with Deloitte in the risk advisory. We used to work with different companies all across the globe. So I'm trying to help the companies to rethink their processes, how they can do better with what they've got, how they can do more with less, how to reduce costs, how to make things faster using data, using technology, how to build their risk frameworks when they can focus their resources where they need it and when they need it, and how to comply with the regulation to make sure that they won't get fined somewhere for a huge amount of money. So one of the great perks when you work with a company like Deloitte, you actually see the picture all across the globe, and semiconductor is truly global industry. So it'll be good to have a quick overview on semiconductors and how they help us to transform to the better future. And hopefully Alice will keep me accountable to time as well, because this is one of those subjects that you can speak endlessly, and I don't want to spend too much on this. So semiconductors, I'm going to speak a little bit about the what are the drivers for the semiconductor companies actually to go green. So what's actually pushing them to go forward in terms of the green path. I'm going to speak a little bit about the strategies that different companies in the industry actually employ to achieve the targets in terms of social responsibility and green and sustainability. I'm going to talk a little bit about what the better future may look like in terms of the industries and how semiconductors actually help to progress the other industries. And I'm going to touch a little bit the buzzword subject, but generative AI usage in the semiconductor industry and very recent study Deloitte did, and it's quite interesting, fascinating subject to quickly touch upon. So if you think about this, the environmental, social impact and the sustainability in terms of semiconductors, so something should incentivize the companies to actually change what they're doing because they're essentially working and making money. Why should they change? So there are a number of factors actually contributing. The first one is the internal drive. So you remember that about a couple of years ago, there was a parade of companies, and it's still continuing when they start declaring net zero by 2030, 2040, 2050, zero waste, etc., etc. It's very good thing because you actually put a very high stake goal, and you have to force yourself to work towards it. So there is an internal drive or internal kind of push towards that thing to happen. The next one is supply chain, and this is specifically notorious for this business, but probably everybody remembers a couple of years ago wearing those masks, self-isolating, and all hurdles in our life and how that make our life complicated. Semiconductor industry is specifically affected by this because pretty much 70% of the semiconductors are being produced in APAC region and across 3 countries pretty much. And semiconductors are highly specialized, which means potentially if one factory somewhere breaks down in Japan, the whole chain, which is multiple handoffs, just stops, which also means your cars are sitting on the production line that you cannot sell them because 2 sensors are missing. Your heavy machinery, which costs you thousands of pounds to run per day, just you cannot use because something broke down, you don't have a spare part. So this is affecting all across the board. Those little brains are pretty much everywhere, and they're quite susceptible to the semiconductor supply chain challenges. So some of the lifespan is like half a year, so in order to produce and use, so you have to be well planned. And if somewhere like Red Sea is closed or something is closed, you cannot produce it in time. It's a huge problem for not only semiconductors but the other industries as well. Regulations. Obviously, it would be great if we will be acting on our best behalf all the time, but usually governments don't trust us in that, so they hold us accountable with different types of laws and regulations. And just to show you the sheer volume of those regulations in terms of sustainability all across the globe, all the major markets, pretty much everybody have got them, and a lot more in working. So there will be more regulations like this, and they have to be conscious as well. Just not only just because they're going to get fined, but also you want to do the right thing as well. And the external stakeholders pressures, all the stakeholders pressures. So we had an interesting survey when we asked the companies who is actually pressurizing you for the sustainability kind of pool. And it turns out everybody wants it. Boards want it, regulators want it, employees want it, civil society, everybody wants this. So which means this probably will happen, which is a good thing. So now, how the companies are actually contributing to this, what kind of strategies they're employing, and what they're actually doing to achieve those goals. So we've seen a couple of strategies popping up all across the globe. So, and they're not mutually exclusive. Sometimes they do a combination, sometimes they focus and double down on one of them, but there are a couple of things that are happening all across the globe to actually help with this. The first one is focusing on scope 1 and 2. So essentially, that's a little bit fancy way of saying this is when we focus on what we're doing and making it better. Just for an illustration, like 300 nanometer wafer fab can use in a day of production 15-20 million liters of water, enormous amount. It's like 8 Olympic swimming pools, and it's like UK have got only 20 of them, like 19 of them. So it's a day, and it can use up to 50,000 households enough worthy of electricity, which is a small house. That's a huge amount of energy which is being used right there. And a lot of companies are recycling this water now as target to address this. A lot of companies are going for green electricity production, including on site as well. And things are this happening more and more. So scope 2 is when you try to buy actually electricity from greener sources or transportation source from renewables, etc., etc. Another another strategy that we see is working all across the value chain. This is when you don't just buy from the better sources, you work with your partners. You work with the people who sell your product, you work with the people who design your product, and you put all across the sustainability goals with them. It's where you partner up, for example, hardware partner up with software to actually offer better package for recycling or something. So there are lots of kind of strategies employed in that kind of area as well. And design, as Ellie was mentioning, in terms of the usage and the kind of the amount of heat and the amount of the space is generating. So when you start addressing this through the design, when you start designing better chips, you indeed can push more capacity in smaller areas or using the same areas for more. The data center usage, I think, is 300% up from 2016 to 2022, but the electricity usage is only 70% up, which means those chips are getting more energy efficient. We're using less, but actually getting more output. And this is the way to solve, one of the ways to solve this, to put the better design in place. Recycle, reuse, obviously self-explanatory, but we're generating millions of tons of waste, e-waste every year in UK only. We're kind of recycling millions of cars in the UK like every year, which means there's a huge, and I'm not sure if all this kind of, we're getting back all the materials like gallium, thorium, gold, and platinum for all this. Sometimes this waste is just going into the landfill, which is a real shame. So better recycling and reusing is happening. We see the buyback programs going on with the larger companies like Apple and Dell, like Microsoft, when they try to buy back their old tech and then kind of give a discount and then reuse the old tech or recycle it properly. And this can go, or it is likely to go into the regulation as well in terms of right to reuse, right to repair. So this is something to watch out as well in the space. Sustainability is a business value, so it's no longer a page in the report somewhere. It's part of the core business values because the companies actually realize that going green and being green is good for business. It's better brand, it's better marketing, it's better sales, and better government incentives. So it's kind of becoming a core business value as well. And last but not least, strategic approach to the sustainability. This means that it's no longer a page in the report. It's more rethinking what you do end to end and building your sustainability strategy into your business strategy, making sure that whatever you do in terms of producing the output is sustainable by design. So you already thought about it. And this is one of the projects I really like because you actually get to see the companies end to end and try to think how you build the whole stuff in for no additional effort. When you do your sustainable bit, not because you do additional effort and exercise, it's just your system and process are built in a way that it gives the right output at that time. So next, now, how the semiconductors actually helping with the other industries? So I'm going to touch only 4 of them. It's numerous industries, so we just won't have enough time for those. Mobility, personal mobility, logistics. If you think about it, all the electrovoltaic cars, all the alternative power propulsion cars, all your electric vehicles, or your ride sharings, these are the things like planning the journey. This is like the better kind of approach to the way you kind of do the transportation questions, maybe better public transportation, and all that requires lots of sensoring and a lot of thinking and behind it. It will have to save a lot. I mean, apart from obvious saves in terms of the emissions and the fuel, it was quite interesting that actually they managed to calculate the amount of time we will save. You know, this wonderful time when you sit behind the wheel in the traffic jam and just you spend it watching in front of your car. And it's 42 billion hours where humans just waste on this kind of traffic jams. And it's just completely useless. That can be taken off our bills and we can spend more time with the people we like, spend more time with the families and do the things we like. And obviously, we cannot go anywhere without sensors and semiconductors here. Next one, smart homes. Also very interesting. These are the things that you go out, your lights are turning off even if you forgot them to turn off. You use exactly the amount of water to wash your hands you need. You heat your house exactly when you need it, how much you will need. You don't waste all the place. So you've got your kind of sensors and videos, cameras, or whatever, everything all across the globe. The house is making your life more comfortable, at the same time reducing the costs. So it's a great, fascinating subject, developing very fast. I'm pretty sure a lot of us have got those cameras and kind of sensors all across our homes, and it's going to grow. It's going to help us to save water, help us to save electricity, and also generate new jobs as well, because somebody have to design those houses, somebody have to implement those smart solutions, somebody have to produce them, and somebody have to kind of service them as well. So it's not only good and better and comfortable for us, but also it creates new jobs and new positions there to benefit for everyone. Third one,
Tigran, really sorry to interrupt. It hurts my soul because this is fascinating stuff and you're on roll, but just wanted to very quickly flag time. I'll give you obviously kind of the final 6 seconds, but if you wouldn't mind kind of just being conscious of time. Thank you.
Perfect, thanks. I appreciate for keeping me accountable. A fascinating subject. Smart grids produce the electricity where we need it, and kind of to have two-way communications. These are our sensors, smart meters. This is like solar panels. I've got one on the roof as well. Smart manufacturing, interesting enough, we already see so there is a survey, we already see better production quality. So this the people are coming back to us and saying, yeah, actually this is smart manufacturing helping to produce better quality, safer, and actually reduce the costs. And last one, probably just kind of rushing through it, the generating AI. 72% of the leaders actually reported that they expect high to transformative impact on the semiconductor industry using this, using the generative AI. They already spend a lot, but they're going to double the spending by 2026. The major areas where they see kind of the application is manufacturing operations, engineering design, and supply chain, all the best back office stuff that Deloitte is also doing a lot across all this board. This is the places where we see potential value. And just last 2 quick examples is the actual application of Gen AI in the semiconductors. So when you produce all this stuff, you need to do very robust kind of defect control. If something is even very small, is not working, you're just throwing it away. Traditionally, the engineers are doing that, and it requires a lot of time. It's very time consuming, and also kind of this recognition process is quite difficult. Traditional AI is already doing this very good for the things that they know, for the pattern that they know. For the new ones, it takes a lot of engineers' time to actually retrain those things. And Gen AI is producing the data necessary to train both the engineers and the older models to actually recognize the defects early on. It's very interesting that it's already kind of there on the front lines. Optimization, so there's design in terms of power, performance, and the
I'm so sorry. You may have forced my hand. I'm really sorry, but just very conscious of time.
Sorry, fascinating subject. Yeah.
Yes, as you said, there's something we can talk about all day, and if it's all right with you, I'm sure we're happy to send these slides to everyone afterwards as well. But yeah, so sorry to do that, but yeah, super fascinating stuff as well, and I really like that data you had at the beginning about kind of the fact that everyone wants this, right? In terms of the drivers, like this is something that stakeholders at kind of every level are very keen for. And yeah, it's super interesting discussion again. Just as a quick nudge to anyone watching, if you have any questions about any and everything that was just discussed, please do pop in the chat, because we'd love to unpack it after the kind of presentations are done. So thank you so much, Tigran. So next up is Professor Paul Meredith from Swansea University. Thank you. And if you'd like to kind of screen share, and yeah, thank you.
Thank you, Alice. Can everyone hear me okay?
We can, yes.
Okay, wonderful. Thank you, Alice. I'll try and get us back on time then. So yes, I'm Paul Meredith. I'm a professor of semiconductor physics at Swansea University. I'm also the director of our brand new flagship Institute for Semiconductor Tech Research and Development called Systèmes. That stands for the Centre for Integrative Semiconductor Materials, and the kind of the secret there is in the word I, which means integrative, and what I'll talk to you about is some of our efforts around this semiconductor innovation for net zero agenda, using multiple semiconductor platforms to create new technology. We are part of the CS Connected cluster in South Wales. You've already heard from Sally at the CSA Catapult earlier, but I'd just like to highlight the fact that South Wales now is the epicenter of UK manufacturing of semiconductor components, not just compound, but also silicon components, and 𝗍𝗲𝗄, for example, into technology. The US power giant has just moved into the region, acquiring our big 8-inch silicon power fab at Newport. So very exciting times down in South Wales. I will go into share mode now, if I may. Okay, so this is the inside of a semiconductor fab. Okay, this is our new facility that we're just opening at the moment. The doors are opening in 2024, and our new facility is a mimic, actually, of the 8-inch silicon fab that's up at Newport that was built by the great Infineon back in the 90s. Our fab, called Systèmes, is at the Swansea University Bay campus. It's an industrial pilot foundry based at a UK university, which is a very novel concept, about 1,000 meters squared of all types of different clean rooms. And the main thing I want to bring over to you is that we are tooled up with industrially relevant tools at 6 and 8 inch for across the semiconductor spectrum, from silicon to wide gap to compound, all the way through to molecular semiconductors and the next generation systems. We also hold a national facility for the growth, epitaxial growth of gallium oxide, if anybody wants to talk to us about that. We're specialists in advanced etch and dielectric, and the fab is designed to be one dedicated to heterogeneous integration across platforms. Okay, I just want to highlight as well that we have some of Britain's only secure ISO 6 clean room incubator space. So come and talk to us if you're interested in that. Okay. And a particular project that we've got running for about 18 months now is called Semiconductor Innovation for Net Zero, or SIN0, as we like to call it. That has two strands. It's about decarbonising semiconductor manufacturing, which we just heard about from Tigran a little bit, but also creating the widgets that's going to drive the net zero future using semicon tech. Okay, so several people have touched on this one, but I'm going to go a little bit deeper in the things I say about some of these, what we call net zero critical technologies. And of course, data comms and telecommunications is key to that. If you really want to know about the state of the art and the facts and figures in this, I direct you towards the International Energy Agency's reports, which are free and downloadable on the net. And here's the actual predictions of data center consumption, 3 cases, low, base, and high case, from the IEA, just published in their 2024 electricity report. And we can see, as other speakers have said, a dramatic increase in the power consumption of data centers, although one must be said, not aligned with the actual growth of data bit rates that we're seeing. So the industry is beginning to get its house in order in terms of consumption. And just so you're aware, by about 2026, that even in the sort of low case scenario, we're adding another country to the world's energy consumption just from the data centers, which is an interesting analogy. And so there's all sorts of green technology that we need to implement. I'm a specialist in clean energy technology and everything around that. And so my focus, is always thinking about not only reducing consumption, but how we feed in the clean power into these data centers. And what we're seeing now is data centers around the world implementing a whole range of clean energy technology, from connecting themselves to big wind farms, to using huge battery banks for backup power. And in fact, the data centers just been built up in South Wales near Newport has something like 87 megavolt amps of diesel generators sitting on its site as backup. That's a horrible, horrible scenario. If ever those generators were to start up, it would probably put a big cloud over Newport for 2 weeks. So, we've got some real issues here. And we've talked about the issues with data center heat generation, and now the really exciting stuff that's going on with interconnections in silicon photonics. A typical data center, for example, has probably got data bit rates of something like 40 gigabits. Intel is predicting that we're going to be up over 100 gigabits within the next 2 or 3 years, simply implementing silicon photonic parallel multiplexing technology. So really interesting times there. My speciality is, as I said, semiconductors for clean energy generation, and many of you will have technology in your houses or certainly in your workplaces, and the base all of this is photovoltaic, so the generation of volts from photons, the generation of electricity from light. And silicon is the dominant technology and has been for about 50 years, accounting for about 95% of the global market. But we're now seeing new semiconductors, relatively new semiconductors anyway, things like cadmium telluride, which is a compound, starting to make a big impact. And then the really sort of exotic top end stuff, the 𝗨𝗏 semiconductors, very efficient photovoltaic materials. And these are the things which are driving photovoltaics into space. And these are the things that are driving really high-end concentrated photovoltaics, these huge plants that one sees in the desert, generating vast amounts of electricity. So there's the unit cell of gallium arsenide for everybody, because I have to put a unit cell up being a physicist, okay? And also we've got some really interesting stuff coming on next generation semiconductor systems. And I think David's probably going to touch on that from Pragmatic, but we also think about the next generation of semiconductors coming along, things called molecular semiconductors made from organic compounds and hybrid organic inorganics, low embodied energy, very flexible types of semiconductors. And of course, you know, the whole point about generating electricity locally is that one often has to invert that electricity from a DC to an AC into the grid. And so the inverter becomes a very critical part of it. And that's not just for photovoltaics on the roof of your house, but it's every form of clean energy is now requiring the highest efficiency inversion into the grid, creation of AC from DC. And that goes to, as well, one of my favorite things on the planet down on the left-hand side there is the 𝗨𝗏 concentrating solar thermal plant in the Mojave Desert that was built about 10 years ago. That generates hundreds of megawatts of clean power from these big concentrating solar thermal systems. And again, critical to that is the inversion of that power into the grid. So every renewable energy technology basically needs semiconductors. And we've heard about two of the superstars in terms of power electronic components earlier, silicon carbide and gallium nitride. And the reason these are really important materials from a basic physical perspective is that these materials have got high breakdown voltages, can be driven at voltages over 1,000 volts. And that means that we've got lower power dissipation at lower currents and therefore much more efficient power electronics. And this is encapsulated in this quite interesting graph. This is Infineon's view of the future, by the way. Other power electronic companies have their views, but this shows you in a very simple manner the power electronic component space, both in terms of the power out, the power that we're managing, and the frequency of the switch, and shows how silicon, that down in the bottom left-hand corner is my single unit of power, which I call my toaster unit. That is probably the most basic power electronic component system in your house. It operates at round about a kilowatt of power and a couple of hundred hertz in terms of switching, all the way up to these really high-end, high-power componentry. And you can see that EV charging off board is right at the boundary between what silicon do now, driving into silicon carbide and gallium nitride. So very exciting times. I drive a 𝗨𝗏. I get 140 miles out of it. If I had a Tesla of the same battery, I'd probably get 220 miles out of it. The reason being my 𝗨𝗏 has got silicon power electronics, and the Tesla that I can't afford has got silicon carbide power electronics, much more efficient. Okay, so what does the future look like? So net zero critical technologies emerging into the future. One thing that nobody's mentioned yet is the interface between semiconductors and the human being, the creation of very efficient, energy efficient and healthcare efficient and cost efficient technology, which is based not just on pharmaceuticals, but the integration of microelectronics into the body. That's called electroceuticals or bioelectronics. It's big in pharma. Watch that space. We've heard about the Internet of Things. We've heard a little bit as well about the cross-utilization of land for the growth of food plus the generation of electricity. It's called agrivoltaics, and it's actually getting very large traction now, especially in high insulation areas of the world. Combined with AI and robotics, this is the future of agriculture. Nobody said anything about hydrogen yet. But critically, the hydrogen economy is significantly, emerging as a part of net zero. And again, there it's efficient generation electrolysis of hydrogen using semiconductor componentry and clean energy systems based on semiconductors. This is kind of one of my favorites. It's really out there. This is Star Wars stuff, but there is real and tangible discussion now about putting semiconductor-based photovoltaics into space and beaming that power back down with RF signals. That's not futuristic. That's happening right now. And one thing we're working on is a really interesting terrestrial idea of light harvesting indoors. This is one of our prototype systems, which is capable of light harvesting and turning that electrical power indoor into local power sources of the milliwatt scale to drive Internet of Things. So that's what the future looks like. And happy to finish there, and Ellis, and get us back on time.
Brilliant. Yeah, absolutely fascinating. Yeah, I think that's so interesting about the kind of agri-voltaics. You know, that's absolutely fascinating stuff. So thank you for joining us, Paul. You know, I mentioned this at the beginning, but this is our second event in our kind of 2024 series. Our first event was actually looking at the kind of you know, South Wales compound semiconductor cluster, and something that was absolutely hammered home by our speakers. You know, we're joined by CSA Catapult, kind of Chris Meadows from CS Connected, and you know, it was the kind of quality of academia, right, as it pertains to collaboration, research, you know, facilities, commercialization. Like, yeah, so super glad you're able to join us, and really interesting. Brilliant. So our next speaker is David Verity from Pragmatic. So if you'd like to share your screen, David.
Yeah, thanks, Alice. Good morning, everyone. Thank you for the opportunity to come and speak to you all today. Bear with me just 2 minutes, and I will get my slides up and running. Okay, hopefully you can see those.
We can, yes.
Grand. So yeah, thank you for the opportunity to come and talk about this challenge and what we're doing at Pragmatic to try and solve some of these things, or try and contribute towards some of these things. So I'm going to talk a little bit about what we see the challenge being, how the semiconductor industry has a role to play to try and solve some of those challenges, and specifically what we're looking at doing at Pragmatic to help contribute to that. So obviously the impact of climate change is growing more pressing by the day. The World Economic Forum estimates that a 55% reduction in emissions is required by 2030 to stay on track with the agreements from the Paris Climate Agreement goals. The commitments, however, for 2030 are projected to reduce emissions by just 7.5%. So if we want to get back on track to net zero by 2050, then digital transformation in the industry is going to play a key role in that. So research from Accenture and from the World Economic Forum have indicated that as much as 20% of the reductions in emissions can come from digital technologies and the transformation that digital technologies will give across multiple sectors. So semiconductors specifically, and obviously traditionally silicon chips as the key part of that is the lifeblood of that transformation. So that spans everything from cloud, edge, item level computing across the spectrum. So some of the most impactful applications with regards to driving that transformation come from item level intelligence. So the use of predictive AI models to harvest and parse data from billions or tens of billions or even trillions of connected devices and understand trends and drive efficiencies at scale is going to be critical to that. On the other side, in the cloud, we're going to have large-scale deep learning models looking at things like climate analytics, research of new sustainable materials, optimization of supply chains, and other things along those lines. At the edge, we've got smarter cities, improved traffic management, smarter electricity grids, more efficient connected homes, and more agile, better efficiency factories. But again, a lot of the impactful IoT applications are about harvesting data from the devices on the item level devices, the billions of devices or tens of billions of devices, by taking physical objects and embedding them with intelligence and giving them the ability to connect and to sense and to some level compute themselves. And that's going to help us reduce waste. It's going to help us encourage recycling and reuse, and really drive the creation of a circular economy around some of the areas that are big contributors to the problems with sustainability and the reach for net zero. And they're just a few examples of how item level intelligence will help us. And there's a lot of scope across a lot of industries, including the semiconductor industry, to kind of help play a role in that. However, there are a lot of challenges confronting the industry broadly, and you know, some of the previous speakers have already touched on some of these things. So supply chains in the semiconductor industry are extremely challenging. They're very complex. They can be very brittle. The demand for semiconductors changes dramatically over time, and new sources of supply are required in order to keep up with those changes in demand. Geopolitical tensions are paving the way for a need to rebalance and to diversify the risks across the world. Skills shortages in the industry. So we need to be building a future pipeline where we can drive the future of the industry and bring people into the industry who are going to help us solve some of the challenges that we're talking about today. And obviously the big one for today is sustainability. So the semiconductor industry is making a lot of progress with regards to sustainability. So renewable energy, abatement, recycling of materials. But it's a big challenge, and it's a big challenge for all of us. And the item level intelligence that we're talking about here cannot come at the expense of creating more emissions to generate that intelligence in the first place. So we need strategies where the stack of technology is at the foundation of the strategy, where we're building from the ground upwards with the technologies that are sustainable. So that's something that we do. That's something that we're looking to do at Pragmatic. So we're looking to apply new technologies where we build sustainability into the process of producing chips right from the start. So like I said, when you're generating the foundation, the electronics and the devices which are forming the basis of those strategies, there has to be some things which are true. So the cost of creating that intelligence can't be higher than the value that it creates. That intelligence has to integrate seamlessly with the item. It has to be invisible for all intents and purposes. It has to be customizable, so it has to be scalable to a whole range of different applications. And if we're going to add that item level intelligence to hundreds of billions of different devices, then we can't be adding significant carbon footprint with every single chip and with every single device that we make. So our saying is we want to be simply intelligent. We're a world leader in the production of flexible ICs. Our technology is low cost, customizable, ultra thin, flexible, thinner than a human hair. So our standard stack is just 30 microns thick. So it's easy to integrate into any items. It's more sustainable. The production has a much lower carbon footprint than traditional silicon-based semiconductors because we use innovative materials. There was some talk earlier about compound semiconductors. That's where we fit in, and our efficient manufacturing processes, really help us along those lines. And that gives us the ability to create these chips that can connect and sense and have some compute capability with a low carbon footprint and enable a new source of supply at scale. So this is a snapshot from our flagship 300mm wafer production line in the northeast of England, just outside Durham, which is entering volume production, has been entering volume production over the last few months. This production line and other ones in the future like it is capable of producing billions of flexible ICs, of flexible chips. We deliver, like I said, radical revolutions not only in the carbon footprint. We are orders of magnitude lower than the silicon industry. We're much lower cost in terms of development and production. But we also offer an extremely short cycle time versus the months it usually takes to make silicon-based semiconductors. The processes we use less energy, they use less water, and they use less harmful chemicals than traditional semiconductor manufacture. So as well as the technology being, from the ground upwards or from the foundations upwards, more sustainable, it also enables you to play a critical role in addressing some of those environmental and societal challenges that I've spoken about and some of the other speakers have spoken about today. So we generate hundreds of kilos of packaging waste every year. The flexible ICs that you could embed into that packaging will enable you to reuse them. It will enable you to recycle them more efficiently. And all of that should contribute to a significant reduction in emissions, sorry. About 25 to 30% of greenhouse gas emissions are attributed to the food industry. But a lot of food that's produced is wasted, something of the order of about 30%. And a lot of that is still good to eat. If we can reduce waste by replacing fixed expiry dates with freshness detectors, temperature sensors, things embedded in the packaging to enable more item level intelligence, then we don't need to dispose of food that's still good to consume. With textiles, so 85% of all textiles end up in the landfill. The fashion industry is responsible for about 10% of global greenhouse gas emissions. If you embed a flexible IC into smart labels in clothing, it enables you to reduce the textile waste. It enables you to run return schemes which work at scale, run authentication on clothes. So it enables a market around second-hand authentication of clothes. And also a lot of these things that we bring pushes down the road towards healthcare and making healthcare more accessible. I think 𝗶𝗶𝗶𝗶 was talking about embedding sensors in the human body and being able to monitor more data from people, authentication of medication, track and trace of vaccines, smart bandages that detect when wounds need, dressings on wounds need replacing to help infections. All are things that you can do down the line with technology like ours. So our mission is to bring our low-cost, low-carbon technology to items all over the world. So there's potential to use our technology in virtually any item to embed item-level intelligence to be able to drive this this need for sustainability and this need for net zero. And our mission is to enable those objects to be intelligent, to be used in the Internet of Things and in an AI-enabled world in the future where we can gather data and process it and understand more about how we're using objects and how we're recycling and reusing them in the future. So yeah, that's everything I have for today, but thank you very much for your time and thank you very much for the opportunity to talk to you. Happy to go into more detail about anything that anyone needs. Just reach out on our website or over socials to us. Thank you.
Good. Thank you so much, David. Yeah. And again, if we're happy to kind of circulate some of these presentations if you'd like as well. Yeah, super interesting. So, funnily enough, one of my other remits at techUK is digital identity. And whilst that's predominantly kind of from the human sense of biometrics, there are really interesting case studies about kind of item tracking. So I'm quite glad you touched upon it because, I do think it's quite, especially right in the fashion industry, things like that. I think in a way it's quite an underrated element of ways in which kind of semiconductor technology can change the basic way we do things. So yeah, it's super interesting. Again, I'll encourage everyone to put any questions they have in the chat. We're about to move on to our final presentation, which will be by Manuel from Dassault Systèmes, and then we'll get on to our Q&A. So thank you. Over to you, Manuel.
Thank you, 𝗬𝗲. So I'm going to share my screen. Do you see my presentation?
We can, yes.
Okay, so good morning, everybody. So my name is Manuel. I work for Dassault Systèmes, a French company, and I am definitely looking forward to deliver semiconductor experience solutions to semiconductor companies, but not only. So first of all, Dassault Systèmes is a multinational company, and we have 7 offices in United Kingdoms to support you in your innovative projects. So I would start my presentation by, of course, going into some evidences that semiconductor is the fuel of our connected world. Basically, semiconductors are used in almost everything, every object that we use today, and we are looking at some of the examples in my presentation today. If we look at the challenges of semiconductor companies, of course, innovation and system complexity is definitely probably the top one, but supply and sovereignty are coming also important. But last, the one that I would like to focus on today is really sustainability. How semiconductors makes us in a position to produce better and greener electronic systems in order to reduce the use, to make them more reliable, to make them repairable, reusable, refurnishable, and at the end, recyclable. So our belief at Dassault Systèmes is that if you are able to create a virtual world, in fact, you are able to extend and improve the real world. And by virtual world, we mean virtual twins. So let us now look at what we mean a virtual twin.
Virtual twin experiences are scientifically accurate computer models of anything. Virtual twin experiences can test any idea before you try it in real life. Virtual twin experiences also help you make sustainable choices at every step. Virtual twins help researchers develop new molecules and materials, eliminating most physical testing. With virtual twin experiences, you no longer have to break prototypes to know they're strong, or work as they should. New manufacturing plants designed for virtual twin experiences operate at top efficiency. As parts arrive and finished goods ship, virtual twins optimize transportation. They build serviceability into product design, so repairs are easy and products last long. A virtual twin shows all materials used in a product, so recyclers know what to recover and how. Virtual twin experiences optimize sustainability at every stage.
So as you can see, virtual twins can apply to almost every object in our life. And actually, Dassault Systèmes is also entering into the modeling of a virtual twin of a human. And that's definitely the next step of our strategy. Now let's go back to semiconductor, and here you can see an example of all the virtual twins, all the different virtual twins we can create dedicated on semiconductor, starting from the virtual twin of the reactor where the wafer will be infused. We can also model the process, the manufacturing process. We can go and create actually a twin, a virtual twin of the equipment that are going to produce that, and we can put them aside in order to create the factory virtual twin. And after, you can use that to create any ecosystem virtual twin that will be managed and powered by basically electronic systems and semiconductors. Now let's have a look on very specific use case. And for today's presentation, I am going to focus on the factory virtual twin and two use cases on an ecosystem virtual twin. So the first, I would like to share an example of a clean room virtual twin that we are developing with Purdue University in the US. And basically what you can see here is that we are able to model everything to have any object that basically will be available in the clean room, and we are able to use any different simulations. For example, here we are looking at how the airflow will make sure particles will stay away from critical zones. We have here an example where we have a chemical reactor, we have the human just close to it, and we're able to make sure that the level of particles that is moved by the workflow is really in the standards. We can also use virtual twins in order to train and develop floors. So those are two examples of what the virtual twin will bring to a company running a clean room, or to a university training students on a clean room virtual twin. My second example here is about automotive. We all have a car, okay? We know we are going into autonomous driving. Autonomous driving means that the car will drive itself, but in order to certify such car, basically, we will need to drive the car by more than 8 billion miles. And driving by 8 million miles is almost impossible because it will take years for that to happen. So the solution is, instead of running a physical car, you are going to run a virtual car on a virtual twin environment, and so that you can accelerate the time and you can drive those 8 million miles in a matter of weeks, of hours, of days. So let's see now an example.
Our products become more and more complex with connected, autonomous and electrified vehicles.
At Dassault Systèmes, we develop industry solutions for advanced driver assistance system and autonomous driving development. With Renault, we have a common goal to engineer autonomous systems that will be free of bugs when the real vehicle hits the road. We are partnering with AD Simulation to run massive simulation of autonomous driving.
Manuel, I think the video is slightly laggy there, and we lost sound near the end. Manuel, you're muted. Manuel. Manuel, I think you're on mute. Hello, Manuel, can you hear us? Hello?
Yes, I can hear you, Alice. Sorry, I did not realize that I was on mute.
Right, I think the video started to lag near the end. So I think as well, just being conscious of time, if you wouldn't mind, you know, you can still have obviously a few more minutes, but if you could kind of continue past, I think there's a few more slides that you wanted to show.
Yes, definitely. I have basically 2 more slides to show. So if you allow me, I will definitely. Okay, thank you.
Yeah, and as I said, in terms of presentations, we can circulate them afterwards. So don't worry, your videos will still be circulated.
So do you see my slide?
Yes.
Okay, so in this example here, we are in a data center. So this is the virtual twin of a data center. And what we are trying to, we have modeled the health flow system, and we are measuring the temperature at different points of the data center. So we want to optimize the cooling system of the data center in order to minimize the electrical consumption and basically operate the data center at the highest possible efficiency. And so here we have a use case where we found unexplained high temperature in some locations. So we do simulate and we can see where are these locations, and we also take decisions to reduce the server load in order to try to minimize the electrical consumption. Okay, and for that, we are using the virtual twin in order to control the cooling system and to input different parameters. And here we are actually injecting a fault. We stop the air cooling, and we can see up to that point where the server is going to reach the temperature where it will shut off. Okay, so this is definitely a simple example of all the capabilities of the what-if scenarios that can be run on a virtual twin. And in my presentation, what I wanted to show you is, first of all, is that with virtual twins, you are able to virtualize almost anything, and you are able to perform a lot of different scenarios, different parameters, different experiments that you can try without wasting any physical resources in order to find the best, the most suitable, and the optimized solution. And if we use virtual twins to develop products that we are going after to sell and to provide the world, so then we will make these products to be more sustainable and greener. So that was the message I wanted to share with you today. Thank you.
Brilliant, thank you so much. And yeah, the virtual twin stuff is really quite fascinating. And I think, you know, as you say, just not possible without kind of semiconductor technology. So so thank you, Manuel. And, you know, thank you again for those videos as well. As I said, you know, all of this will be kind of circulated afterwards. And yeah, that brings us to the end of our 5 speakers. So thank you so much. Genuinely, really interesting stuff. So thanks everyone for joining us for that. Now, I'd like to introduce Mia, who is our former program manager for Net Zero. If you want to quickly say hello, Mia.
Yeah, so hi everyone, and great to be on the call and kind of now chairing the short panel discussion that we now have. Great to hear all of the presentations from you all, and obviously great to kind of have this event showcasing the role that semiconductors really can play in driving forward our net zero ambitions. So I guess starting with actually Tigran, given that you weren't able to kind of just finish off the final part, and you mentioned kind of the impact of Gen AI on semiconductors and how this is kind of supporting semiconductors to deliver on net zero. But if you could just expand a bit on that, so whether that's around kind of more efficient manufacturing operations or kind of you started on that trail, but yeah, just expand on that. That would be really useful.
Yeah, thanks, Mia. And again, and thanks to Alice for keeping me accountable for the topic. This thing is fascinating. I don't know, different people feel different about things. It's quite weird to get fascinated by the small brains of computers, but this thing is indeed fascinating. And generally, there are 3 things you can do with the semiconductors, right? If you kind of put in larger buckets, you can design them, You can produce them in fabs, or you can package, test, and all those additional activities that you've got there. And Gen AI can help all across the board. And based on the survey that we did with the semiconductor leadership all across the world, they see transformative impact of this new tool set. There were two examples that were there. First one is training and retraining the models that spot the damage or spot the defects. So in order to kind of do it faster and pick it up off the line earlier and kind of pick up the defect pattern early on. So they actually they use Gen AI to generate huge amount of data to train those models and to train the engineers to spot those patterns. Another example there was a quite interesting one when they used the Gen AI for design, which shortens the time frame of the design of that. Traditionally, you use obviously a lot of electronic tools, but you've got humans in the loop, and then you do the prototype and test it. To the Manuel's point about the virtual twin kind of approach, the whole thing. So you test it, it takes 4 weeks, months, and maybe years to design one thing. And using Gen AI and tools like Manuel was describing, you actually shorten down this thing to days and hours, which is a huge kind of improvement on the scale, especially considering the cyclical nature of the industry and kind of the longer spans in the supply chain. There are multiple uses. I just don't want to take too much time.
No, thank you. That is a really kind of useful overview. And Professor Paul, if I come to you, so in your presentation, you kind of mentioned the industrial pilot foundry, and it's great to see that kind of this is contributing to the UK semiconductor capability, but also has received kind of government investment. So I guess on this, and given our role at techUK, we're keen to understand, I guess, what more maybe the government could do or policy could play in enabling kind of the growth of the UK semiconductor capability, but also obviously kind of in fostering net zero and sustainable practices. If you have kind of any insight on that, or what could shift the dial?
Yeah, you've asked me my favourite pet question. Thank you, Mia. So just for everyone's perspective, the investment down at Swansea in 1,000 metres squared of dedicated kind of RD&I pilot fab is roughly about 55 million at the moment. So that's about 30 million for the infrastructure and about 20 odd million for the tool sets. We started building this pre-COVID. It was a different world. In fact, we came out of the ground on the August of the first lockdown. So it was a really challenging build for us, as you can imagine. And we saw it as a really important endeavour in kind of creating some post-COVID progression and some post-COVID sort of good news, and it's turned out that way. If you wanted to build our fab right now and you priced it up, it would be double that. And the tool sets would be about a third more expensive, and the supply chains around the tool sets would mean that you're waiting probably 3 times as long as we endured for the same tool set. So I think that's really important for us to understand. And we're very fortunate in that, for example, we're so closely connected with you know, the big players along the M4 corridor, 𝗍𝗲, 𝗍𝗲𝗃, microchip, that we're able to kind of use their supply chains. Okay, so that's a call to arms. And the reason we built a pilot foundry is because we needed to be able to service what you might think of as the intermediate stage between, you know, one device on a chip going then up into the big fab. So we're probably capable of dealing with, depends on the device structure, a couple of hundred wafer starts a month, which is probably more than any other university in the UK, to be perfectly frank with you, and up with the sort of private foundries. Okay, so that's why we did it. What can UK.gov do? Well, very soon, I think this month, is the 2nd year anniversary of the UK semiconductor strategy. Okay, so that was a strategy that was issued. Some people think maybe that it wasn't a comprehensive strategy, but there's been a lot of consultation about where we should be going as a nation. And many of you on the call would have been consulted on what infrastructure we need and what sectors we want to go into. So we're in a sort of election period, and our advice is that there's been some rollout of programs under the strategy in the last sort of 6 months. You might see a little bit more before the election, but that next year and the year after are going to be big rollout elements. So what can the government do? Well, number one, the US CHIPS Act and the European CHIPS Act are absolutely central and enabling us as a community, and many of the people on this call, David and Sally, all of us have got a massive opportunity to leverage relatively small amounts of private-public funding in the UK into enormous buckets of funding in the Europe and the US. And the homework question, anybody from DCIT is on? The homework question for you is how you facilitate efficient entry of UK entities into those two very big initiatives. Because, we're a relatively small country, we've got a rapidly growing semiconductor sector, we've got new companies just funded, and let's get involved with the big initiatives around the world to be a global player.
Thank you, Paul. That was an extremely comprehensive and useful overview. And as you mentioned, need to ensure that the UK stays in the kind of global race for this, alongside the US's CHIPS Act and the EU too. So coming to you, David, I guess with a similar question, but also maybe a slightly different angle of kind of potential challenges or barriers to growth of the UK kind of semiconductor industry at the moment, speaking from kind of your own perspective.
Yeah, sure, thank you. So not to cover maybe a slightly different angle then, talent and the retention of talent and the growth of local talent in the UK, I think is a massive part of that. So there's a rich history in the country of developing not only fabless and design type of businesses, but also manufacturing, and we've been able to kind of leverage some of the the older industries which have now kind of died out in the UK, and brought people with the skills in process engineering, equipment engineering, and these high technology type of environments like semiconductors. And we're trying to then bring forwards the skills into another generation of people. But it's important we keep that pipeline filled and that interest in the industry going. And what we're looking to do to try and facilitate that a little is ways that we can use our technology to generate interest in universities and in schools, and that's an area where I think we could work alongside the government, to try and generate interest, enable students and enable people in universities to be doing the entire process of what you need to do to generate a semiconductor chip, from design all the way through to manufacture and testing at the end. And we really need to make sure that pipeline is continuing. Otherwise, we increasingly will need to recruit from abroad, which becomes prohibitively expensive. It becomes more challenging. So yeah, making sure that we keep that talent pipeline filled, I think, is a critical part of that.
Hey, thanks, David. And yeah, that's absolutely something we kind of hear across the board. And techUK, we're, for instance, calling for a digital skills toolkit 2.0 to kind of enable that pipeline in the government's critical industries, of course, one of which is semiconductors. And coming to you, Sally, I guess, with a similar question on kind of the skills talent gaps, but also the awareness, I guess, of the role that kind of semiconductors do play in the UK's net zero ambitions, but also just kind of society, obviously a key role in EVs, for instance, or the future there. Do you think there is enough awareness? And obviously we know that CSA are doing a lot on this, but yeah, any thoughts around that question?
Yeah, so we're currently involved in an exercise called skills foresighting, where we're trying to look and assess what the skills gap is for compound semiconductors and for the semiconductor industry across the UK. And a lot of that is trying to raise awareness. I kind of feel like I accomplished something once my mum could name a few compound semiconductors. I feel like that was a win. But typically when you talk to people who aren't in the industry, and who aren't technically, like, from a STEM background, it does become quite challenging to get across the importance. We've done a lot of events with schools. We're all STEM ambassadors at CSA Catapult as well. And, it's quite easy to just take a phone and be like, well, it's a phone that works. But trying to get the younger people interested, or anyone really, into what's in that, and what influence can you have on the technology that you use every day. I think that's kind of one of the main challenges we see. And for people as well, younger people, to be aware of the jobs market that's out there. We attended a SEMI event recently, and it was all around, you know, showcasing the industry and what's out there. Especially younger people are more interested in sustainability. And you can say, look, you can contribute towards a more sustainable future by working in semiconductors. And it's trying to make that connection and just raise the awareness that is quite challenging. I think we are getting there slowly, but I think we can't just rely on the next generation to fill that skills gap. We don't have the time to wait for kids to come up and just be interested. We need to look at how we can reskill some of the existing workforce, like David said, to be able to use their skills now.
Thanks, Sally, and really great to hear of the initiative that CSA are leading on to. And if I come to the final question for Manuel, so obviously we know that there is kind of a huge growth potential here. An estimate, for instance, that there's kind of $1 trillion growth potential of the semiconductor industry in coming years. But how do you think that the UK can kind of position itself strategically to kind of capitalise on this, whilst also kind of focusing on sustainability goals? So I guess that kind of does come back to potentially the role of the government. But yeah, any thoughts on that?
Yeah, thank you, Mia. So basically, so we used to work with all the semiconductor companies worldwide. What we can see today is that you have several geographies that have embraced a very, very strategic policy towards semiconductor. And the goal is basically to attract companies, help universities train students to become workers, technicians, engineers, and also to nurture innovation through startups in order to create a semiconductor ecosystem locally. So UK is very, very well positioned for that. Okay, first you have ARM is basically the semiconductor IP provider worldwide leader. Okay, you have also an ecosystem near Cambridge, for example, near Coventry. So you have all the things, all the ingredients to become one of the top 3 regions for semiconductor innovation. Okay, now what does it take? It takes a bit of everything. First of all, you need universities. You need universities to propose courses based on semiconductor. You need, after those students need to have a place to work on and to use the latest technologies in order to innovate and to create semiconductors of tomorrow, and especially the ones that will drive the transition to a sustainable and circular economy. So the answer is we need to focus on the right things, and the right things is really looking for better semiconductors to ensure our connected world of tomorrow. Now we have to create the conditions for that: universities, startups, big companies, and help from the politics in order to make this happen. But you can do it, and I'm definitely counting on you.
Yeah, no, thanks, Manuel. And as Paul mentioned, it's really around kind of the delivery of the semiconductor strategy now, whilst also aligning with the policies from Department for Energy Security and Net Zero and ambitions around there too. So I'll hand back to 𝗬𝗲, as I can see we only have 1 minute, but thanks for a really, really interesting insight, all, an extremely great webinar.
Brilliant. Yeah, thanks, Mia, and thanks so much, everyone, for joining us today, both speakers as well as those of you who've attended. I want to emphasise this isn't just kind of a one-off thing. We do have a regular drumbeat of semiconductor-related opportunities, events, insights, thought leadership, things like that. techUK, as I said at the beginning, we are also, we play quite a prominent role in the CHIPS Coalition, which, it's a free kind of group to join. We meet quarterly, and it is kind of like an industry voice in which we can kind of communicate, keep our finger on the pulse, communicate certain things to government, etc. So I'd encourage you. I'll put the links in the chat in a moment. But again, thank you all so much for joining. It's been super interesting conversation. As Tigran said earlier, we could talk about this all day. All of the material and slides we'll make available afterwards. And, I appreciate there were some questions in the chat as well, which we couldn't get to. So we're happy to pick any of those up and pass them on to relevant people as well. If anyone wants kind of email intros and ways you can kind of collaborate together, please do reach out to us. But yeah, apart from that, thank you so much for joining us, everyone.
Thanks all.
Thank you. Bye.
Thanks.
Cheers. Bye-bye.
Thanks. Bye.